This is the gist of what we learned so far. Integration with respect to x using the disk or washer method. And when you're revolving the object about x-axis, so basically finding the larger area, you're finding the smaller area, and then do the subtraction, taking the definite integral. But if you decide to use the shell method, for the shell method, you have to be careful because the axis of revolution is y-axis. So basically the functions that you're using are in the form of x, but the axis of revolution is with respect to y-axis. So the same as what we saw before, taking the integral and calculating the volume using washer method or disk method, revolving about y-axis, which is basically writing everything in terms of y, versus applying the shell method when you're revolving about x-axis, converting everything into y. Let us practice a little bit. This question says, use the method of cylindrical shell to find the volume generated by rotating the region about the y-axis. So let's see, what do we have here? We have y equals to x squared minus 6x plus 10. And the second y is negative x squared plus 6x minus 6. Right, okay. What's the visualization? How do we visualize this and then set up the integral? Okay, both of these are quadratic functions. One of them opens up and the other one opens downward. Let us find the intersection between them. To find the intersection between them, we need to do a little bit of algebra between curves. So set y is equal to each other. X squared minus 6x plus 10 is equal to negative x squared plus 6 times x minus 6. So bring this term to the other side, the linear term as well, and the constant. So move all to the left-hand side. You get 2x squared, negative 12x plus 16, and set it equal to 0. Make sure to factor 2 to simplify it as much as you can. You get 2 times x squared minus 6 times x plus 8 equal to 0. So you can use delta method or x equals to negative b plus minus square root of b squared minus 4ac or divided by 2a, or use factoring. You're looking for two numbers that their multiplication is positive 8 and their addition is negative 6. So those numbers are x minus 2 and x minus 4. If you multiply negative 2 and negative 4, it is equal to 8. Then you add them together, it becomes negative 6. So factoring is sometimes very easy to use instead of using a quadratic equation. So by setting this equation equal to 0, x minus 2 is 0, so x is 2. X minus 4 is equal to 0, so x is 4. So we found the boundary for our x. X is bounded between 2 and 4. Now remember that you are rotating this guy with respect to y-axis. With respect to y-axis, using the shell method, everything needs to be written in terms of x We're lucky here. Everything is already written in terms of x. Let's take a look at visualization and see what do we have. So let me graph this. Right here, I know x is bounded between 2 and 4, so it makes my life much more easier when I do the graphing. I know these two are intersecting at 2 and 4. So let me just graph this as much as I can without being worried about the detail too much. You can use Desmos or any other graphing website to have a precise graph. But for now, I'm not really worried about these two because they are intersecting at these 2 points. So suppose this guy is moving this way, and this is your negative x squared plus 6x minus 6 because it opens downward. So you have negative x squared plus 6x minus 6. And down here, you have the second parabola. Suppose it opens this way. And since it opens upward, it is x squared minus 6x plus 10. So you're basically taking this region and rotating this guy about y-axis, right? So the rotation or revolution about y-axis is basically taking this object here and do the rotation exactly the same to the other side. Again, I'm just graphing this as best as I can. And we are using the shell method. Okay. So in using the shell method, the volume, as you remember, is the definite integral of a to b of the circumference times the height. And then you take the integral with respect to x. The circumference, hey, it is just rotated about y-axis. So basically, you have this distance, you're looking at the base. So it is 2 pi x. The circumference is 2 pi x. Suppose this is a random base that you're looking at. And then the circumference of this base is just 2 pi x. And to calculate the height, you have the top function, the larger y value, minus the smaller y value. So the height, so the volume is equal to the definite integral 2 to 4. The circumference is 2 pi x. And the height, you get negative x squared plus 6x minus 6 minus the smaller y value, which is down here, is x squared minus 6x plus 10. Then you take the integral with respect to x. So here you can change this to 2 pi x. 2 pi times x, and the top function, the maximum y value, which is located on negative x squared plus 6x minus 6. And then you do the subtraction, and the rest is basically taking the integral as you saw before. So the volume is equal to the definite integral 2 to 4 of 2 pi x. You can simplify this as well. You get negative 2x squared, and then you have plus 12x, and then you have negative 16. dx, make sure to distribute this x into parentheses, then take the integral. So the volume is equal to definite integral 2 to 4 of 2 pi. Then if you distribute x into parentheses, negative 2x cubed plus 12x squared minus 16x dx, which in turns is equal to 2 pi. And then here you have negative 2 over 4 x to the 4 plus 4x cubed minus 8x squared. X ranges between 2 to 4. So the volume is equal to 2 pi. Let us plug in 4. You get negative a half times 16 plus 4 times 4 cubed minus 8 times 4 squared. Minus, when you plug in 2, you get negative a half, 2 to the 4th. Let me see. So why I wrote down 16, 16 should be over there. This is basically just 4 to the 3rd. And then 4 to the 4th, so negative a half, 2 to the 4th plus 4 times 2 to the 3rd minus 8, 2 squared. So if you do the algebra, let me do the algebra, but I don't have enough space. Just give me a moment. I'm going to erase this later, so let's write down the whole thing. The volume is equal to 2 pi. And then here you have, let me see. Maybe we can factor out 4 squared to make it a little bit easier between these terms. And you get negative 16 divided by 2 plus 16, and then minus 8. And then minus, here you can factor out 2 squared as well. So you end up with negative a half times 4 plus 8 minus 8. Okay, it's not that bad. These two get canceled out. So the volume is 2 pi times 16. You get negative 8 minus 8. So this term becomes just 0. And you have minus 4 times negative 2, which is give you 8 times 2, or 16 pi. So the volume of this object is 16 pi using the shell method. Let me make it a little bit smaller for you so you see what's going on. Okay. So the steps with all the algebra for you guys. So let us move on to the next question. The same process. We're going to apply the cylindrical shell method to find the volume when we are rotating it about y-axis. So this is our next question here. Y squared is equal to x, and x is equal to 2y. So shell about y-axis. So what's the visualization? Let's take a look at this visualization. You can find the intersection first as well. To find the intersection, you have x equals to y squared. And at the same time, you can write down y as x divided by 2. So wherever you see y, you can just plug in x divided by 2. So x is equal to x over 2 to the second, or x is x squared over 4, or x squared is 4x, or x squared minus 4x becomes 0. If you factor out x, you get x minus 4 equal to 0. X is 0, x is 4. So we expect these two graphs to intersect at 0 and 4. Well, okay, let's take a look at it. So graphing x equals to y squared. At 0, it is 0. And if you take square root of both sides, this is y equals to square root of x. And down here, you have y equals to minus square root of x. So this guy consists of two functions. One function is on top, which is y equals to square root of x. And one function is down here, y equals to negative square root of x. This guy itself is not a function, okay? It includes two functions, but y squared equals to x. It doesn't pass a vertical line test. And the next guy that you have is y equals to x divided by 2, which is an increasing line, behaves like this. So y is x divided by 2. Perfect. And we know that they're intersecting at 0 and 4. So this point is 0, and this point of intersection is 4. And we are revolving this about y-axis, everybody. Perfect. This is your region, and you're revolving this region about y-axis. So roughly, this is what you have. Now we're going to apply the shell method. So this is just a revolution about y-axis. So if you think about this as small shells or cylinders, this is the base. This is a typical base for your cylinder, right? You assume this is like this. So let me just erase this little part. Perfect. Just looking at this small shell, trying to analyze the base and the height for you. So for the base of this shell, it has a circumference. The circumference is equal to 2 pi times the radius, but the radius is changing between 0 and x. The radius is x. So this is the base. What about the height? For the height, well, the difference between the maximum y value and the minimum y value gives you the height. So for the height, what do you have? You have square root of x minus the smaller y value, which is down here. So this is your height, the height of the shell, x divided by 2. Very good. So now we can find the volume. So let me erase this part of the board so we have more space to do the calculation for the volume. So the volume using a shell method is the definite integral. What's the boundary for our x? X is bounded between 0 and 4, and this is the radius as well, am I right? It's just moving 0 to 4 of the base, the circumference of the base, which is 2 pi times x, times the height, which is square root of x, minus x divided by 2, then dx. So make sure to distribute x into parentheses, simplify as much as you can, then take the integral. So the volume is the definite integral of 2 pi x times, let me just write 2 pi x a little bit further. Don't want this to intersect. 2 pi times x times square root of x minus x squared divided by 2 dx. So the volume is 2 pi and 0 to 4. Let us not forget that, 0 to 4. And here you have x times x to power a half, which is x to power 3 halves, minus x squared divided by 2, then dx. So to calculate this integral, this guy becomes 2 pi times, if you add 1, you get 5 divided by 2, so 2/5 x to 5 over 2 minus, and here if you add 1, you get 3, so you get x to the third divided by 6, and x ranges between 0 to 4. We're not really worried about 0. The only thing we're worried about is 4. So the volume is equal to 2 pi 2/5, and instead of 4, I'm going to write down 2 squared because it makes it easier for me to simplify this. 2 squared to 5 divided by 2 minus, here just write it as 4 to the third divided by 6. So the volume is 2 pi times, here 2 and 2, they get canceled out, so you end up with 2 times 32 divided by 5 minus, should we factor out anything or just leave it as it is? Okay, let me just do the multiplication. 16 times 4, 64 minus 64 divided by 6. Or you could simplify it further. You have, let me see, just 32 divided by 4. Since I don't have enough space, trying to jam everything here by simplifying beforehand. So here you have 32 divided by 3. Then you can factor out 32 as well. So you get 64 times 2/5 minus a third. And you get 64 pi divided by 15. So this is the volume of this object.